So in this chapter, normally, if I think I also little bit talk about the conversion in our previous chapters. But when we talk about as a chemist or scientist that we need to calculate the amount of molecules, amount of compound or amount of atoms to initiate any kind of chemical reaction. So it is very important to know the quantity for that. But as you all know that atoms are very tiny particles, and if we consider, you can see here that one hydrogen atom mass so tiny that you can see the 10 negative exponent 24 1.6. So it's so tiny, so small that even we cannot see it, correct? So then how we can quantify the things, even how we can calculate the number of atoms, number of how many moles or in gram. So that's why what scientists did some experiment that's long time ago, and scientists find one thing here about using the carbon. I want to just tell you some basic before going slide to slide. Okay, if everything burns, like fire happen and everything, what you can see black ash, correct? So black ash is carbon, and this is the most stable atom on our earth. So you can imagine that everything burning out, everything breaking, but left is carbon ash, correct? So that's why then initially scientists find that we can take some standard atom, and this is the carbon isotope, and not only carbon isotope carbon, because carbon have a most stability, and that's why they consider the carbon, the system of the relative atomic mass is based on the mass of the isotope of carbon that contains 6 neutrons. So that's why initially the scientists take carbon as a standard value and then consider the relative, not the exact, relative atomic mass in compared to carbon. Like was assigned a value of exactly 12 atomic mass. You know, if you look into the periodic table, you will see the carbon atomic number is 6. Carbon, where is carbon? Here we go. See, carbon atomic number is 6, but the mass. You know, from now we will also learn how to utilize the atomic mass, because still now we learn about the atomic number, and I want to revise the atomic number, proton number, but we know the atomic mass equal to proton plus neutron together, okay? So then we compare with that value. So one atomic mass unit equal to mass of this carbon, that's 12. So the atomic mass of carbon was chosen as the standard because this carbon is very stable, as we said. So now you can see the how we can initially beginning of the our the long time ago and beginning we study after the scientists investigations that we will use the carbon as a standard, and that's exactly like 12 mass. And we use also AMU, means atomic mass unit. Remember, this is the relative. So the question next we will also learn the quantitative one. So don't mess up with the relative and quantitative, because when we are going to learn the quantitative, then we will use the gram. And without the quantitative, when we will talk about the relative mass, then we will talk about the exactly the AMU, like that. So if now we consider the atomic mass of magnesium, so how we can actually compare. So we will compare with the carbon, because carbon is our standard. So in that case, if we look back into the magnesium, calcium, magnesium. Here we go. So magnesium is 1224. So that means if we compare with the carbon, it looks that this is 2 times heavier than carbon, correct? So this is the way we initially found the atomic mass in compared to the carbon. But then you can see here one term, the gram atomic weight refers to the atomic weight expressed in gram, and this is the quantitative. And the number of atoms for any element, see, this is the thing I think one day I asked you that, do you guys know it or not? The number of atoms for any element is 6.022 10 times 23, which is known as Avogadro numbers according to his discovery. So that means when the atomic mass will be expressed in gram, that time we will say this is gram atomic weight or gram atomic mass quantitatively. However, we have to be fulfill the condition that this amount of magnesium must contain 6.022 10 power 23 atoms. And you may see the one line here for any. So now next we will little bit talk about the Avogadro number, because sometimes the beginning student confused about that why this number is conditions, why this number is fixed. So we will talk now. So now if we ask you the relative mass, so you need to be use the atomic mass, but you need to be use this unit. But when we are talking about the quantitative and gram atomic, then we will say that this refers to the atomic mass or weight in grams, but the number of atoms must be fulfill or contain this number, and this is called the atomic number. And this is nothing, this is just a number. There is nothing complicated. Like if you consider the 1 dozen banana, we know there is a 12 banana, correct? So the Avogadro number is also just a number of atoms, number of particles, number of molecules, how you express it. So when we have these two conditions fulfilled, then we will say this is the quantitative atomic mass or weight for particular atom or particular molecules. Calculation of molecular mass. Now we already know little bit the molecular mass of any molecule or formula unit is equal to the sum of the masses of all its atoms. So I'm not sure you guys already know or not. So let's little bit go. So if we consider this is H2O, we know this is the formula for water, and this is actually one molecule, so water formula. So this is how the water is composed: 2 atoms of hydrogen and 1 oxygen atom, correct? So if we need to calculate the molecular mass or molecular mass, then what we have to do, we have to find the mass of each atom, and we need to sum all the atom mass in a molecule or compound. In that case, how many hydrogen we have? We have 2 hydrogen, and we know the hydrogen mass is 1. This is exception. So this is 2.02 AMU. If we consider oxygen, till now we learn about so many atomic number. From this this chapter, we will also see how we can utilize the mass. So in case of oxygen, we can see here the 8 and 15.99. 15.99 means 16, correct? And that's why normally in average we write the 16. So in that case, for 1 oxygen, 16. So 2.02 plus 16, 18.02 AMU. So therefore, the atomic mass of water is AMU. Now, the procedure is almost same, but when we will ask you the gram, then you need to write the gram. But value, not 100%, I mean in 99% is same, but there are few exceptions. So we are not going to talk too much about it, because I need to also keep within your syllabus. So I need to give you that this is basic idea, that first comes the relative atomic mass calculations, and this is the relative atomic mass, and then we will talk about the gram atomic mass or gram molecular weight or whatever we say when we express in a gram, and condition that these molecules or atom must contain the 6.02 to 10 times 23 atoms, which number is known as Avogadro number. Here we have the another example of this molecule C2H6O. So if I need to ask you the molecular mass relative in AMU, you have to do the similar thing. So we have the 2 carbon. In that case, remember, you will use mass, not the atomic number. Got it? This is you have to remember. So you guys will use the mass, not the atomic number. So for the 2 carbon, 24.02, for the 6 hydrogen 6 and 1 oxygen. So this is your atomic mass in AMU, and this is the relative atomic mass. Now let's go back here. Before going more calculation, I want to clear the 2 terms mole, the Avogadro number and also mole. Now I will go back then there. We already saw the gram atomic weight means the when the any kind of atoms or molecules weight we expressed in a gram, and this atom or molecule must contain the 6.022 times 1023 atoms or particles, whatever you say. So in that case, chemists choose the mole as unit for counting a large number of atoms or molecules. In that case, we can consider the dozen like 12 or anything. So this is how chemists use the mole, and you know, the Avogadro number, as you say, the number, just number of atoms or particles. So when we can say this is 1 mole atom or 1 mole molecule, we have to adjust it. So 1 mole atom or molecules means it will have the atomic mass that we show in the periodic table for any atoms, and it should contain the number of particles or atom this. That time we will say this is 1 mole oxygen, 1 mole nitrogen, 1 mole X, 1 mole Y, 1 mole magnesium, like that. And where we get the 1 mole information? You remember the balancing of chemical reaction, the coefficient number. The coefficient number represents a mole. So now let's see some example that will make you clear if you have confusion anything about the mole, number, or gram atomic weight. So as we said that anything that contain this amount of atom or molecules or anything, and the gram weight, atomic mass we can express in a gram, and according to periodic table, then the condition is fulfilled as a 1 mole, and also 1 mole means this number of atom. Now the thing is that, see something, 1 mole object, I mean how we can represent 1 mole objects equal to 6.022 times 1023 objects. 1 mole atoms means 6.022 1023 atoms. Look into here. 1 mole ions represent this number of ions. 1 mole molecules represent this number of molecules. Now the trick, 1 mole of anything means this number of anything. Now you got it? So 1 mole of anything that should contain this number of particles. This is the fixed number, okay? Just a number, first thing. Second things, now if I ask you the 1 mole of molecules, and here is not molecules, here if we say atom, then will it be same? The number of this Avogadro number will be same. 1 mole object, this amount of object. 1 mole atom, this number of atom. 1 mole ion, this number of ion. 1 mole molecules, this number of molecules. But if I ask you that I have oxygen molecule, 1 mole oxygen molecules contain this amount of oxygen, I mean the molecules contain this number of particles. Now, can you tell me then how about this number of particles for 1 mole atom oxygen. Come here. So oxygen and oxygen molecule and oxygen atom. We know O2 means we have the 2 oxygen atom, correct? So when we will talk about the molecule to molecule, number is same. But if we talk about molecule to atoms, that means it will not be same, because one molecule's oxygen means 2 oxygen atom. And now I'm asking you for the 1 oxygen atom. So that time you have to either divide or times on the basis of what we need to do. Amount we need to adjust. Otherwise, when we will talk about ion to ion, the number of particle is same. Atom to atom, same. Object, same. Dozen, same. Anything, same. But when we will have this type of like 1 mole atom to 1 mole molecules, or 1 mole molecules to 1 mole atom, that time we need to adjust. So this is the just only one twist you need to remember. Otherwise, this is, I think, that 3-4 terms I will come now here. You guys are now clear that how we need to calculate the mass. We know that we have to add the atomic mass for each atom, and we have to sum all the number of atoms in a molecule or compound. Then we can calculate the mass. In that case, there are 2 types of mass expression. One is the relative mass that we express as an atomic mass unit. Another is the gram atomic mass, when we express in gram, and that time we need to write the gram. And when we expressed in a gram, this is totally quantitative. And we find 2 more things, 1 mole and Avogadro number. 1 mole means any atoms or any molecule when, or atom, let's see the atom, that 1 mole atom or molecules mean when they will have the gram atomic weight and weight expressed in gram and contain the 6.02 to 10 times 23 number of particles. So when these 2 conditions are expressed in a gram and the Avogadro, this amount of particles, then we will say this is 1 mole. So chemists choose 1 mole as a quantity to calculate the molecules or compounds or atoms, whatever we say. So that's something basic we clear. And now let's see the another example is we have here. This is little bit of bigger. We already know how to do that. But remember, here we have parenthesis or bracket. So when we will calculate the mass of the bigger molecules or compound, we need to be remember this type of twist, because when we have a parenthesis, see here the ammonium phosphate. So that means nitrogen mass, and obviously it will be times 3 times, because we have 3 after parenthesis, correct? So 3 nitrogen. Hydrogen how many? 8, 4, and here is a 3. So 3 times 4, 12 hydrogen. How many phosphorus we have? 1 phosphorus. How many oxygen we have? 4. And also remember, here we are not going to use the atomic number. We are going to use the atomic mass, and that is this number. Proton plus neutron number is together is called the atomic mass number. So now we are very clear about it. Let's move on. Molar mass and diatomic molecules. Diatomic molecules we very frequently use in the chemistry or science lab, and this is really crucial, important to calculate or quantify always. And in case of diatomic, sometimes we see the molecules to atom, atoms to molecule. That's why I made you a little bit of clear here, that do not be confused when we have this type of conversion. Now we can see here. Calculate the molar mass of 1 mole of hydrogen atom. 1 mole of hydrogen atom means we have to calculate the mass of hydrogen atom and expressed in a gram. So 1 times hydrogen, and we know this is the mass. So this is the, and we know that here we have 6.02 to 1023 not just number of particles, hydrogen particles, because we know this is 1 gram hydrogen, but can we see 1 gram? we don't know the how many hydrogen there are to, correct? If we measure something mass, we know, we can see, correct? But when we talk about the atom molecules, they're very tiny, huh? So that's why we need this type of measurement. Second, let's see the difference that I just taught. Calculate the molar mass of 1 mole of hydrogen molecule. This is first come the molar mass calculation. So when we are talking hydrogen atom, this is one hydrogen, correct? But if we are talking about molecules, so how many hydrogen we have? Here is a 2 hydrogen atom, correct? So we must have to be multiplied with the total number of atoms. So this is 2, A is 2, so 2. So it will be here. So when we are calculating the molar mass of 1 mole of atoms or molecules, it will not be same in that case. Now let's see the conversion using the mole. In this chapter, I will upload this just after the lecture finish, because these things we have the lecture as same. But here we have little bit of straightforward and a very clear explanation. So that's why I prefer here. But when we will finish here, I will again go back to our presentation, what we have here. So you guys can practice and compare. Yes. Yes, just after lecture I will do, because today morning I edited this. So I could not get time to upload. Yeah, so just I will finish here and then I will upload here. And this is really very clear and clear explanation I made here. So yeah, you can see here in this chapter we will see this kind of conversion: mole to gram and mole to molecules or atom. When we need to convert any kinds of amount of moles of any molecules or atom, we need to use the molar mass. Okay, because if I ask you the molar mass of hydrogen molecule, 1 mole of hydrogen molecule, so we know that this is going to be 2 gram 1 mole, correct? So that's why we will use mole to gram conversion. We will use molar mass. But when we need to convert the mole to molecules or atom, we need to use the number of, Avogadro number. Why? I just say you that if we say that one atom, 1 mole hydrogen atom contains 6.022 1023. This is for the 1 mole. So if I ask you for the 5 mole, 7 mole, 0.5 mole, you can just do that normal mathematics, correct? So that's why we need this number. This is like a standard value when we did the measurement kind of thing. So we need this number for conversion moles to molecules or atoms. And this is all about today's chapter. You guys just need to do some practice math. And this chapter, normally we give you the math question. There is not so much have option to give you the multiple choice question. And this second part of your examination, like from the 10 to 18, it's mostly math based. Okay, so we need to practice math here. Where do we see mole? These are coefficient in the balance equation. We all know now. So if we see this is the balanced equation for production of ammonia. So what we can say from this balanced chemical reaction, I can say that here 1 moles of nitrogen react with 3 moles of hydrogen to prepare 2 moles of ammonia. So we will get the mole information from here. So when we have standard mole information and I ask you that XYZ that go and make ammonia for me and this amount. So when you have this amount mole information, you can calculate how much nitrogen and hydrogen need to run your reaction, whatever the amount your supervisor asks you, correct? You can do that because you also know how to calculate the mass of them, correct? From the periodic table knowledge. So That's why you can calculate how much really you need. If it is either in mole or in gram, we can calculate it. Now let's see the conversion, moles to gram. Okay, here some format change, not all the things come. Just a minute, I have another format, so I will just upload. I think I did here. Yeah, I think this one. Yeah, that was, I was also see when I talking about the second slide. Let's see, is this also the same thing? Oh no, give me a moment, I have it. Yeah, sometimes format change when we transfer to Microsoft to PDF, or even the computer to laptop, laptop to computer is often change. Yeah. Let's, yeah, this one. Sorry, I need to. Okay, let's keep here. Okay, I will go back here. When we edit something, then sometimes I didn't notice it that some format convert. Actually, if I do the presentation in the Microsoft PowerPoint, it's easy. We have lots of options to write, but when we come to the BB Ultra and upload our information, our option to present is very limited. I mean, edit or something. So now we are going to see the conversion of mole to gram, then we will see gram to mole, then we will see how to do the mole to atom, and atom to mole. So this type of conversion. So this is not the toughest one, but lots of conversion. Sometimes the direct one-step conversion, or sometimes the multi-step conversion. That's why you need, yeah, see, I think, yeah, so this one, I also could not see when I was, but I didn't see that it can be too much. So let's go back now. Yes, so we are now here. Yeah. So we already did, okay, let's see. Molar mass of any substance, mole to gram. So now we will talk about mole to gram. So the molar mass of any substance is the number of grams contained in 1 mole of that substance. So this is our actually the conversion factor. You know, this is the similar that we learn for the measurement. So whatever the unit we need to convert, we have to write on a top, correct? So here mole to gram. Here moles to gram. So molar mass, we know we have to use the molar mass. So we have to be use this conversion factor. So molar mass equal to is the number of grams contained in 1 mole of substance. So now if I ask you the 1 mole of hydrogen molecule, so you will write here the 2 gram. See here, 2 gram. So then you can do for whatever the moles you are, I am asking you or you are asked. So that's the similar way to do the conversion that we already learned. But difference is that we have to find the molar mass from our periodic table. We need to calculate for 1 mole, because we know the 1 mole of any substance or 1 mole of anything contains the amount of that atom that we have in the periodic table in grams, and it contains 6.022 and 1023 times of particle or atom or molecule, whatever we say. So in that case, when we are going to convert moles to gram, we have to use this conversion factor. Now if I ask you, this is mole to gram. So this is mole to gram. Now if I ask you gram to mole, so you have to just alter it. So in that case, mole will be go to off second for second one and gram will be come down. Correct? When we are talking about gram to mole. So remember, we will also see here, but just I said I'm making clear. So when we will talk the mole to gram, so gram is our final unit we have to find out. So according to our rule, the conversion factor, so gram, you know, whatever the amount of gram will go top and mole, 1 mole will come down for 1 mole. But if we ask you gram to mole, because you need to do the both way conversion, maybe anything can come, that time just this mole will go top and this gram will go down. And rule is one, that whatever that you need to find out, you have to write on the top, and from which unit, the standard value, you need to write on the down. So let's see, the example is here. What is the mass in gram of 4 moles of hydrogen? For hydrogen, it's very easy because we know that hydrogen mass is 1. So for the 1 mole, it should be 1 gram. So for the 4 mole, it should be 4 gram. But this is not can be easy for other atoms or molecules. So in that case, you need to know how to calculate, correct? So now we will go to our procedure, how to calculate. So molar mass of, we are asking here the hydrogen molecule. So the molar mass of hydrogen molecule equal to 2.02 gram divided by, for 1 mole. 1 mole, this amount. Now you ask how you go, because I know that the hydrogen mass is 1 and 1.01 or something if you look back into the periodic table. Yep, 1.007. So this is very negligible. Even if you can, if you want, you can ignore the after point, this in case of hydrogen. So that's how I calculate. I have the 2 hydrogen atom in 1 molecule of hydrogen. So that's why I got the 2.02 gram hydrogen per 1 mole of hydrogen molecule. So if I know my conversion factor, we have to just multiply whatever the amount we ask in the question. So this is our conversion factor and we did it. And I said that please strict to follow this rule, conversion factor. Then you never have an option to mistake that whatever the amount I have, I need to multiply or I need to divide, because it will be automatically fixed when you will write the conversion factor correctly, correct? It will automatically fix. So this is the answer for 4 moles of hydrogen molecules. So I think you now know the how we can convert the moles to gram. Let's see the another example. How many grams of ammonium phosphate are contained in 2.52 moles of ammonium phosphate? So this is, see that that's why you need to learn how to calculate the atomic mass in gram, correct? Because if you don't know, you cannot do that math. So in that case, you remember the 149.12, but we already show you in our previous slide, so we can just go back to see, just revise how we calculate here. Here we go. See, the ammonium phosphate for 1 mole, 149.12. This is revised how you need to calculate it. As I said, the second part is all about math mainly. Who likes math, they are going to do very good in second part. Anyway. So we have for 1 mole, this is for the 1 mole, we have in gram because we have to convert mole to how many grams. So we are converting mole to gram. So we must must have to be gram on the top for 1 mole ammonium phosphate, because if we know the amount for the 1 mole ammonium phosphate, so we can calculate for any other mole. So in that case, this is our conversion factor, and whatever the amount of mole we have to calculate in a gram, we will multiply with that, and then see how the unit will be nullified. This unit will be nullified. So we have 2.52 times 149.12 in gram ammonium phosphate. So this is the answer. I hope this is straightforward. You got it, but you have to practice because we have different conversion. Like we are now doing the mole to gram. You may have gram to mole. Then we will say the mole to molecules or mole to atoms. Even we can, when we will see the gram to atoms is one step, but if I ask you the mole to atoms, so what you have to do, we have to do 2 steps. So mole to gram, gram to, like that. So that's why you need practice for those chapters. Let's see. See, now we come the gram to moles. How many moles of benzene? Till now we saw the example, the how many grams. How many moles of benzene C6H6 are present in 390 grams of benzene? So, what information we can have? We can have the information for the atomic mass of benzene for the 1 mole, correct? Because 1 mole atomic mass in gram for the benzene, how we can calculate? We can go back to the periodic table, huh? We can find the atomic mass of carbon, we need to multiply with 6. We have to find out the mass of hydrogen and multiply with 6. Whatever the amount we will get, this is the gram of benzene for 1 mole. This is the standard for 1 mole. So then, if we have this for the 1 mole, we can calculate for any other quantity in moles. So this is how here our CF or conversion factor. This terms actually I mainly use that because I think if I can do same way and I can give into your brain, and then you guys will never gonna forget it. So CF here we have to calculate how many moles. So mole will be go top and gram will be come down. But anyway, first you need to calculate the molar mass, correct? So molar mass, you can write that this is the gram per mole. But if you are confident, you don't need this line actually. You don't need this line because you need the mole top, because you need to calculate mole here, gram to mole conversion. So when you will calculate this benzene atomic mass, you need to write the bottom and 1 mole of benzene top. So, and you have 390 gram. So this gram benzene unit will be nullified. So top will be 390 divided by 78. If you want, you can just do the calculation and match if the answer is correct or not. Because sometimes typo happen. Though a long time I use this slide, so it's fine. Yeah. So then you will find the amount of mole you need for a specific this gram of benzene. Any question? You guys are okay? Any question? Yeah. Second, see now the mole to atoms or molecules. To convert from mole to atoms, we already checked that actually in this chapter we just need to know this base, because you know how to calculate the molar mass and then here. So we already learned that if we need to convert from here to here, we need to use the Avogadro number. So let's move on. To convert from moles to atoms or molecules, or vice versa means it can be molecules to mole or atoms to mole, that's why. So the conversion factor is like that. So if this is atoms, mole to atoms, so we will be doing like that, and if we need to calculate the atoms, we will just do upside down. So whatever the unit, Again telling, we need to calculate, we have to write on the top per 1 mole. So here what we have, so we will write like that. 1 mole molecules means it contains 6.022 times 1023 molecules, or 1 mole molecules contain this number of molecules. So situation is same, just difference is that what you need to calculate, convert moles or molecules, mole or atom, that's the things. 7 mole of nitrogen contain how many nitrogen molecule? Look into here. So we have to calculate first the 1 mole nitrogen contain how many molecule? We know this is the fix that 1 mole nitrogen molecule contain 6.022 10 times 23 nitrogen molecules, and this is fixed. This is we know, and this is scientists already fixed by their experiment. And I want to repeat the one more time this one, and that 1 mole object means this amount of 1 mole, or atoms means this amount of atom. When we talk ion means this amount of ion. 1 mole molecules means this amount of molecule. 1 mole anything means 1 mole this amount of anything, and this is a standard value, Avogadro number. So let's do that job. So we have 1 mole of nitrogen, this amount of molecules. So it's very simple. We can calculate for the 7 mole. And most of the times I have seen that some students do mistake here. I mean, which unit is going to write top or down. So even they do the conversion factor correct, but sometimes students confuse that I need to multiply and divide. That's why I always tell students that follow the conversion factor and stick on that. That which unit I need to find out, I need to write on the top. And then when your conversion factor is ready, you just need to multiply whatever the amount you have into your question. So if you just keep in mind these two things, you will never have any mismatch for that. Because this kind of math sometimes, say 2-step calculation, 3-step calculation, even I think you see your practice problem, the measurement, 5-step, 6-step calculation, just path, convert to convert, like that. So you have to be strict in this formula, and if you have this type of math on the basis of step and time, you have the number of points is also fine. So if you just keep mind and do correctly, you will have lots of points there. Second, 7 moles of nitrogen contains how many nitrogen atoms? See the twist here? When you saw this type of things, obviously, if I am available, you can ask me that is it correct or typo mistake? But this is not a typo mistake, okay? As we say, the molecules to atoms or atoms to molecules also can be asked, huh? Because if this is nitrogen to nitrogen, we know this is the amount, and this is very straightforward. But when we are asking from nitrogen molecules to atoms, then we know that 1 molecule of nitrogen contains 2 nitrogen atoms. So then our number of molecules will be changed. So that is the one twist you need to remember in this chapter. So whatever the molecules we have, this is for the 1 mole, this amount. But we didn't ask you for the molecule, we asked you for the atom. That's why we have to multiply for the 2 nitrogen atom, and this is the amount. So this is only one twist you have to keep in mind. Let's see one more example. How many sodium atoms are contained in 2 mole of sodium? So we know that's very simple, that 1 mole contain this. For 2, you just need to times 2. So if you need to calculate atoms, number of atoms will go top. How many number of atoms or molecules? So we know that this is the Avogadro number for 1 mole of same atom or molecule. And how many molecules of water are present in 5 moles? So same calculation, do the practice. Now we have not so much. Then I will go back here, because when I will finish this presentation, 90% is done. So we will just go here to review what we have, so that, yeah, you guys can practice both. And when I will finish today, I will upload from here to the Blackboard, so you will not have any problem. Gram to atoms or molecules. To convert from gram to atoms or molecules, we require the conversion of grams into moles first, and second, moles to atom. As I said that you need two-step conversion. So how? So gram to, and for avoiding the mistake, it is always suggested, I personally suggest that first when you read your job, write the path. Path means we have to do two steps. So gram to mole and mole to number, correct? Mole to atoms. So if you write little bit of like that, this is step 1. Personally I write the CF1 and from here to here, and from here to here CF2. So there is no chance to mistake. This is totally up to you. You will do this job separately or you will calculate together. So let's see example. See here. How many molecules of hydrogen chloride, HCl, are there in 25 gram of hydrogen? How many molecules? Asking molecules. And you have gram. So first you have to calculate gram to mole. And second, mole to molecules. So see here. So gram to mole. So we know the 36.45 gram HCl for 1 mole. Now you can ask how you get. I got because I know the molar mass of chlorine from the periodic table. Sorry, this is carbon. Here we go. 35.43. And for the hydrogen 1, so I know this is going to be 36.45 gram. And for the 1 mole of HCl. So for the 25 gram, you need to multiply. And whatever then you will nullify this gram HCl, so you will have a mole. And we know that for the 1 mole HCl, we have this amount of molecules. So for the 25 mole, 25 times multiplication. Now got it? So this is how we have to do that. Finally, we have, oh, we don't have here final. I supposed to have another. Anyway, so this is the conversion. Now I will go back to your lecture. So we learn here that how to calculate the molar mass, what is the Avogadro number, and relative molar mass, and how we can calculate the mole to mass, mass to mole, mole to gram or gram to mole, even the gram to atom, mole to atom. So 3 type of conversion, but 3 conversion is 6 because vice versa can be also happen, correct? So total 6 conversion we learn here. So now let's go back to our lecture. For our lecture, we have to go here, materials. Today is the 13th, correct? See how the time is running. This is just suggestion. Please try to be regular last few days because so many analyses I have started and also the time is so limited. It's very difficult that I will manage the makeup, correct? So try to be that we don't need hand. And also this is just a reminder that when you do any kind of quiz on the blackboard or anywhere, please try to use the Google Chrome and Stable. Because if you use Safari not going to support the every format. So Safari always make a problem. Like yesterday, one student, I have to maybe share 5 questions. It was okay because I was with you, correct? Just think that I was not with you, so you have to ruin your test. And maybe it was depend on instructor, that instructor will give you chance or not. Because this is just kind of glitch sometimes happen with software to software. Okay, so that was just some example. So you can see the last chapter. Oh, by the way, today I'm going to open the quiz. Since I gave you the recitation 11, so I'm going to give you the quiz 10 because topic 10 we didn't do anything, correct? So topic 10 and 5 questions because you remember that when I use the 1 chapter, 5 question, 2 chapter, 10 question. So yeah, just for okay, update, yeah. Okay, so in your case, let's see here. So we already done our chapter, but I have to little bit of do compatibility with our lecture what we have. So stoichiometry. We are now going back to our chemical reaction and begin try to quantify amount of reactant and product. So stoichiometry is very important when we need to quantify any amount of reagent, or we can say that either reactants or product. So we know the reactants are on the left side and product what we got after the chemical reactions. We know this is our balanced chemical reaction, and as we just explained that what information we learned from the balance, the mole information. So here is the another example that 2 mole hydrogen gas can react with 1 mole oxygen gas can produce 2 mole water in liquid. So describe the combining ratio of the reactants to product. Now we already learned. You remember I also gave you some supplement material for the previous chapters. You remember how to do the mole ratio. So we already have that. If we consider, oh, sorry, I have to download and go there. Otherwise, who are watching here, they are not going to get it. Just a minute. Yeah, guys, this is the last few days. Try to come to join in the class. Chem lecture 13. Just a minute. Yeah, so you remember that we can make a ratio between the hydrogen and oxygen, 2:1 ratio. If we consider the hydrogen and water, 2:2 ratio. If we consider the water to oxygen, 2:1 ratio. So any kind of ratio we can make from the balanced chemical reaction. And also we can calculate the amount in a gram, correct? That just we learn. Yes. So let's see. 2 moles, yeah, that's we already know that we use for the calculations. Stoichiometry means quantitative calculation for the reactants or products that you have to. See, but what is the mole? Mole is a unit that represents a very, very big number. And see here, 1 mole equal to this amount of particle, and this contained called the Avogadro number, and 1 mole contain 1 mole specified the gram molar mass. And this molar mass we find from periodic table. So I think that the way I explained, that's very straightforward, correct? So step by step. So you guys can just match if you think, yeah. So see, to calculate the molar mass or molecular weight of a compound, you sum the atomic mass, same thing that we learn. This is the kind of thing that you can just do the practice here. How much would 1 mole of calcium sulfate weigh? So you know you have to write the formula of the calcium sulfate first, correct? So calcium SO4. So you know, do you know the sulfate valence, charge or calcium charge? I think what is the sulfate charge? 2 or 3? You remember? Anybody remember the charge of sulfate? This is polyatomic anion. So you need to just do the crisscross, so you will find it. Yeah, calcium sulfate, both are 2, 2. So both are 2, 2. So plus 2 and negative 2. We know that when we write the formula, we have to do the crisscross. So the negative point or right side charge will come as a down the plus 1, and plus 1 will come here. But if you have the equal number of charge, you don't need to write it. So in that case, just a reminder. So if we have this, you can calculate and you can find the gram. This is simple type of questions, math, but you really have to go for the conversion. See here now. Number of moles, number of particles, or number of atoms or molecules, whatever you say. So in that case, we can connect number of moles or particles by using Avogadro. So now you can, I think, see that why I use those presentation, because step by step very clear, huh? And same thing is here. So you guys can go through here. And now we know that how to write the formula, a conversion factor, and do it. So just do as a practice, okay? Number of gram to mole or mole to gram. We already done it. Do the practice here. Yeah, number of moles, number of gram. So how you have to do. So molecular weight in a gram or molecular mass, you can calculate here from the help of periodic table. See, they also show, I mean, this nice colorful presentation. They also show the atomic number and atomic mass for, and you are always allowed to use the periodic table, so you will have it. So how we can connect to the number of particles, moles, grams. We also already learned like that. How do you connect number of particles to the gram? Use the Avogadro number, two-step, as we said. We need to do like two-step, vice versa. Either the mole to gram to atom or gram to mole atoms. So vice versa, same things. Connecting gram to particle, gram to atoms. So gram to mole, you know, we said the two-step, two-step. Same. Actually, these both are same. So you guys can take lots of example you have here. Yeah. And you have some questions here. How many molecules of water are in this? Same thing, but you have to just keep in mind, do the practice, do the math, and choose your correct answer. Yeah, you don't have anything else. Okay? More practice. Same things. So practice the questions. You have lots of questions, correct? Here and here. So, yeah. So that was actually the topic 13, stoichiometric equation, how we can quantify the amount of reactants or products in terms of gram, in terms of atoms or molecules. So if you have any question, let me know. And next we are going to do our recitation. Any kind of question, recitation, we are here. So actually lecture is